Hi folks, this is Karim Raouf for IT Visualizer channel. They will continue our lab, the Matrix Labs, the video number 116. We have been discussing in the previous video the following. We have closed the topic of troubleshooting Windows operating system and application freeze. It was a very good topic and very important for most IT administrators. We have seen that I have used as a reference the two videos from the YouTube channel, which is called Tech Savvy Production. This is a channel that was created by Mr. Lo van der Pol, which is an IT professional person. In his channel there is a lot of useful videos discussing different IT topics. There was two videos in his channel talking about the freeze situation of the Windows operating system and application, and I have used these two videos as my reference for explaining this topic, and also the documents attached to these two videos in his channel, which is very detailed and very simple. I urge you all to download these PDFs and see also his videos and subscribe to his channel. Today I will discuss the same topic, even though we have finished it before, but I will discuss it using the AI tools. I have already feed up Claude 3.5 Sonnet with the three PDFs of Mr. Lo van der Pol concerning the topic of Windows operating system and application freeze, and I will ask Claude to explain it in three different ways. The first way is to explain it as if I am a junior IT and explain it in simple terms and explain the common pitfalls of such a subject or such a topic, and then I will ask it to explain the topic using hands-on exercises to make it more practical, to educate us more using practical examples or practical exercises. And then the last way to explain it through a learning dialogue. We will ask it to explain this topic explain this topic in a learning dialogue between a senior IT and a junior IT. This is also a good way to explain a topic through dialogue between a non-technical guy and a technical guy, or a simple technical guy and a senior technical guy, just to make it more rich, and so we can learn more using this method. So these are the three methods that we'll use to explain one topic. Each method will give us a view about the topic and how we can learn it. These are different ways to explain the topic: through exercises, through a learning dialogue, through a simple question and answer. All of this to help us explain or help us to learn the topic in depth. Let's see how we can do that using Claude. So here I have already gone to Claude, and then I have gone to projects. Let me show you how I have done this. I have go to projects in Claude and ask him to create a project, and then I have this project called Windows Application Lockup and Freeze Troubleshooting, and then I have feed him up with the PDFs of Mr. Lo van der Pol. Here they are. These are three PDFs. Take note that you have a capacity for your project knowledge. This is, I think, a special space for the user to feed up the AI with the documents he needs to analyze or to explain. So here I have feed them up with the three PDFs. Two are the slides of Mr. Lo van der Pol, or the PowerPoint slides, and the one for the PDF that contains the notes of the videos he has already created. And I have a couple of chats with Claude. The first one is troubleshooting Windows applications and freezes and lockup, and the first prompt or the first thing I ask Claude to explain is to explain Windows application lockup and freeze troubleshooting using the three PDFs in your project knowledge as a reference. Like, I am a junior IT, show me this concept, how it works, provide a real-world scenario, and include common pitfalls to avoid. Very simple, straightforward prompt. It should explain it to us in a simple way. This is one of the ways that we can explain any topic using a prompt like that. We are a junior in the field that you are trying to explain. You are a junior in this field, so you need to explain a topic to a junior in the field that you are currently trying to explain. Okay, something, for example, you are choosing a IT topic, so you are a junior in the IT field, so the AI will make the answer simple. Okay, so let's see the answer of Claude and how he will explain this topic. Just a moment. So here you go. This is the answer. Let's try to read it out loudly.
By following this systematic approach, you'll be better equipped to diagnose and resolve Windows application lockup and freeze troubleshooting. Share. O0. Guide for Junior IT Administrators. Understanding Windows freezes and lockups. When a Windows computer or application freezes, it can be frustrating for both users and IT administrators. A freeze or lockup occurs when the operating system or an application stops responding to user inputs. Understanding what causes these issues is the first step to resolving them effectively. Two main types of freezes. Single system kernel/API call hangs. When an application makes a request to the operating system, like opening a file or accessing a network resource, and that system function doesn't return properly, causing the program to hang indefinitely. Infinite loops or recursive calls. When an application enters a loop or recursive function that never completes, consuming resources and preventing normal operation. Systematic troubleshooting approach. Step 1. Identify the problem details. Before diving into technical solutions, gather information about the problem. Device type. Is it a physical server, workstation, laptop, or virtual machine? Scope. Is it affecting a single application or the entire system? Timing. When does the freeze occur? During startup, shutdown, or when performing specific actions? Frequency. How often does it happen? Every time, intermittently, at specific times? Scale. Is it affecting one computer or multiple machines? Step 2. Determine the current state. Your approach will differ based on whether the computer is currently frozen. The computer was frozen but has recovered. Step 3. For currently frozen computers, try these access methods. Remote desktop or Citrix if available. Out-of-band management tools like HP ILO, Dell DRAC, or IBM RSA. Test ping connectivity. May show packet dropping or high latency. Try accessing administrative shares, // server name /C$. Attempt Control plus Alt plus Delete. Remote administration tools, computer management, server manager. Step 4. Diagnose the issue. Use these tools to gather diagnostic information. Event Viewer. Check application and system logs for errors around the time of the freeze. Look for application error events. ID 1002, application hang. Review system event logs for service control manager errors. Check for error event IDs 2019/2020 with source SRV/server. Performance monitor. Run perfman/report to generate a system diagnostics report. For workstations, use perfman/rel to see reliability history. Reliability monitor. Provides a visual history of system stability. Highlights application crashes, Windows failures, and other issues. Memory dumps. Configure Windows to create memory dumps during crashes. Use tools like dumpchk.exe to verify dump file integrity. Analyze dumps with WinDBG to identify root causes. Tools for application freeze troubleshooting. Essential diagnostic tools. Windows built-in tools. Event Viewer, eventver.msc. Performance Monitor, Perfman. Reliability Monitor, Resource Monitor, Resmon, Task Manager, Nearsoft Utilities, Blue Screen View, for analyzing crash dumps. What is hang? Helps detect which process is hanging.
Just a moment, guys. So let's continue, guys.
Hanging. App Crash View shows details of application crashes. Full Event Log View. Enhanced Event Log Viewing. Advanced Debugging Tools. WinDBG. Windows Debugger for detailed crash analysis. Dump CHK. Validates memory dump files. Memory Pool Monitor. Poolmon.exe. For kernel mode memory leak detection. Real-world scenario. Troubleshooting a freezing line of business application. Scenario. Users in the accounting department report that their financial application freezes randomly while processing month-end reports. The freeze requires a forced restart of the application, sometimes resulting in lost work. Troubleshooting steps. Gather information. Ask users about exact actions leading to the freeze. Determine if it happens at specific times or when performing specific operations. Check if it affects all users or just certain machines. Initial checks. Check Event Viewer for application errors around the time of freezes. Review available system resources during application use. CPU, memory, disk activity. Verify application and Windows versions and updates. Create a monitoring plan. Copy. Logman create counter month-end freeze. udomain /username *fbincirc vmmddhhm max 500c / computer name / logical disk asterisk / computer name / memory asterisk computer name network interface asterisk computer name paging file asterisk computer name physical disk asterisk computer name process asterisk computer name redirector computer name server asterisk computer name system asterisk computer name terminal services asterisk computer name processor asterisk computer name cache asterisk. Sigh, 10 seconds. Start the logging before the user performs the month-end process. Stop it after the freeze occurs. Capture and analyze freezes. Configure the application server for complete memory dumps. Use Process Explorer to create a dump of the frozen application. Analyze the dump with WinDBG to identify the stack trace at the freeze point. Root cause identification. Analysis reveals that the application is waiting for a database query to complete. The query becomes blocked during peak database usage times. Performance monitor logs show high disk latency on the database server. Solution implementation. Work with the database team to optimize the problematic query. Add indexes to improve query performance. Implement connection pooling to better handle concurrent requests. Increase transaction timeout values to prevent premature application freezes. Resolution. After implementing these changes, month-end processing runs without freezes, and users can complete their work without interruption. Common pitfalls to avoid. Jumping to conclusions. Don't assume hardware issues without evidence. Don't immediately blame third-party software without investigation. Avoid reinstalling Windows as a first response. Incomplete data collection. Failing to capture performance data before and during freeze events. Not configuring proper memory dumps. Missing relevant event log entries. Ineffective memory dump analysis. not setting up symbol paths correctly in WinDBG, misinterpreting stack traces, overlooking third-party driver issues, quick fixes that don't address root causes, just restarting services or applications, adding more RAM without identifying memory leaks, upgrading hardware when the issue is software-related, poor user communication, not gathering detailed information from users about the issue, failing to document freeze patterns and triggers, not communicating troubleshooting status to affected users. Best practices for prevention. Proactive monitoring. Set up performance baselines when systems are running well. Implement monitoring to detect trends before they cause freezes. Review event logs regularly for early warning signs. System maintenance. Keep Windows and applications updated. Regularly check for driver updates, especially for critical hardware. Maintain adequate free disk space, at least 15 to 20% free. Test changes. Test application updates in a staging environment before production. Validate driver updates before wide deployment. Create a rollback plan for any significant changes. Documentation. Keep records of freeze incidents, causes, and resolutions. Document troubleshooting steps for recurring issues. Maintain a knowledge base of application-specific freeze solutions. By following this systematic approach, you'll be better equipped to diagnose and resolve Windows application lockups and freezes, minimizing downtime and improving user experience.
So this is the answer of Claude concerning the topic of the freeze. We have seen a lot of steps, a very straightforward answer, maybe not that simple, but it summarizes what we have been talking about for 6 videos. All of the steps, all of the programs needed to verify the freeze, the performance data collector set, a lot of things actually. So again, here I'm asking him to design a set of hands-on exercises on Windows application lookup and freeze troubleshooting based on the 3 PDFs in your project knowledge as a reference. So let's see also the exercises provided and see how we can implement all of what was explained in his previous answer. Let's begin from here and ask him to continue to read out loud from here.
Windows application lockup and freeze troubleshooting. Hands-on exercises. Required environment. Windows 10 or Windows Server 2016/2019 workstation or virtual machine. Administrative access to the system. Internet connection for downloading tools. Basic understanding of Active Directory and Windows administration. Optional. A test domain environment for domain-related exercises. Exercise 1. Identifying and accessing a frozen computer. Objective. Learn how to identify a frozen system and the various methods to access it remotely. Scenario. A user in the accounting department reports that their Windows 10 workstation has become completely unresponsive while running the monthly financial reports. The user can move the mouse, but clicking does nothing, and they can't access Task Manager with Control plus Alt plus Delete. Step-by-step instructions. Set up the scenario. On a test Windows machine, open several resource-intensive applications to simulate high load. Run the following PowerShell command to simulate a system freeze. Don't worry, this is reversible. PowerShell. Copy. Start process file path PowerShell.exe. Argument list. Command while $true, $A equals 1. 10,000. For each $I and $A. $B equals $I asterisk $I. Windows style hidden. Try accessing the system remotely. From another machine, try connecting via remote desktop. Copy. MSTC lomitko v target computer. Attempt to ping the target computer. Copy. Ping target computer. Try accessing administrative shares. Copy. Net use / target computer / C $/user. Domain / administrator. Use alternative remote access methods. Open computer management. Right-click Start Computer Management action, connect to another computer, enter the target computer name. Use PowerShell remoting if enabled. PowerShell. Copy. Enter PS session computer name, target computer, credential, get credential. In the simulated freeze. If all the above methods fail from the target computer, try PowerShell. Copy. Get process name PowerShell where object $_ CPU. GT50 stop process force. Expected outcome. You will learn which remote access methods may still work when a computer appears frozen, gaining valuable insight into how different freeze scenarios affect accessibility. Verification. Successfully connecting to the frozen computer via at least one method and ending the simulated freeze. Exercise 2. Using Event Viewer to diagnose application hangs. Objective. Learn how to use Windows Event Viewer to identify the cause of application freezes. Scenario. A user reports that Microsoft Word freezes when they try to save large documents. You need to identify the root cause using Event Viewer. Step-by-step instructions. Set up the scenario. Download Not My Fault, a Microsoft tool for simulating crashes, from the sysinternals website. https://docs.microsoft.com/us/sysinternals/downloads/and Create a folder called c:/temp/tools and extract the Not My Fault files there. To simulate an application hang, run Not My Fault with the hang parameter. Ensure you save any important work first. Copy. c:/temp/tools/in-notmefault.exe/hang. Open Event Viewer. Press 1+ or to open Run dialog. Type eventver.msc and press Enter. Examine application logs. Navigate to Windows Logs application. Look for events with error or warning level near the time of the hang. Focus on event ID 1002 application hang entries. Double-click on the most recent application hang event to view details. Analyze the hang event. Note the application name, version, and faulting module. Check the
Let's see why it's stopped. Let me try to open it back.
record the timestamp to correlate. Bucket information for clues about the cause. Record the timestamp to correlate with other system events. Check system logs for related events. Navigate to Windows Log System. Filter for critical, error, and warning events around the same time frame. Look for events related to service failures or resource issues. Generate a filtered log view. In Event Viewer, click on Create Custom View. Set the following filters. Logged, last 12 hours. Event level, critical, error, warning. Event logs, applications and services logs, Windows logs. Include keywords. Add any relevant terms based on your findings. Name the view application hang analysis and save it. Expected outcome. You will have identified the specific error events related to the application hang, including the process name, hang duration, and potential causes. Verification. Successfully creating a custom view that shows relevant error events and being able to explain the likely cause of the application hang based on the event details. Exercise 3. Configuring memory dumps for freeze analysis. Objective. Configure Windows to generate memory dumps when applications or the system freezes and verify they can be analyzed. Scenario. Your organization has experienced intermittent system freezes on several workstations. Management wants you to implement proper memory dump settings so that when these freezes occur, diagnostic information is captured automatically. Step-by-step instructions. Configure system crash dump settings. Press 1+R and enter sysdm.cpl. Go to the Advanced tab. Click Settings under Startup and Recovery. Under Write Debugging Information, select Complete Memory Dump. Ensure the dump file is set to %system root %\memory.dmp. Check Overwrite any existing file. Click OK to save changes. Configure page file settings for dump collection. In the same System Properties dialog, click Performance Settings. Go to the Advanced tab and click Change under Virtual Memory. Uncheck Automatically Manage Paging File Size for all drives. Select the system drive, usually C. Select Custom Size and set both initial and maximum size to value equals physical RAM plus 300 megabytes, e.g. for 8 gigabytes RAM, set to 8,500 megabytes. Click Set and then OK on all dialogs. Enable keyboard-initiated crash for testing. Open Registry Editor, regedit.exe. Navigate to both. HKY_local_machine /system/ current control set /services /I8042 PRT /parameters. HKY_local_machine /system/ current control set /services /did /parameters. In each location, right-click New DWORD, 32-bit value. Name, crash on control scroll. Value 1. Close Registry Editor and restart the computer. Verify dump configuration. After restart, open Command Prompt as administrator. Run the following command to check dump configuration. CMD. Copy. Reg query. HKLM /system/ current control set /control /crash control /s. Verify crash dump enabled equals 1. Complete memory dump. Test dump creation optional in test environment only. Warning: this will cause your system to crash and restart. Save all work before proceeding. Press and hold the right control key, then press scroll lock twice. The system should generate a blue screen and create a memory dump. Install and use dump.chk to verify dump integrity. Download and install Windows debugging tools from the Windows SDK. Open Command Prompt as administrator. Navigate to the Debugging Tools directory. CMD. Copy. cdc:/program white space files white space left parenthesis x86 right parenthesis /windows white space kits /10 debuggers /x64. Verify the dump file with dump.chk. CMD. Copy. dump/c:/windows /memory.dmp. Expected outcome. Your system will be properly configured to capture complete memory dumps during system crashes or freezes, allowing for detailed post-crash analysis. Verification. The registry query shows correct dump settings, and if testing was performed, dump.chk confirms the dump file is valid and complete. Exercise 4. Using Performance Monitor to diagnose application performance issues. Objective. Learn how to use Performance Monitor to capture system metrics during application freezes and analyze the results to identify resource bottlenecks. Scenario. Users in the marketing department report that their graphics editing application becomes unresponsive intermittently throughout the day. You need to identify if this is related to system resource constraints. Step-by-step instructions. Create a custom data collector set for performance monitoring. Open Command Prompt as administrator. Create a data collector set using the Microsoft recommended command. CMD. Copy. Logman create counter app freeze. udomain /administrator * f bin circ. vtmmhmm. Max 500c /logical disk * /memory / network interface * paging file * physical disk * process processor system psi 5 seconds. This will create a data collector set named App Freeze that captures key system metrics every 5 seconds. Start the data collection before reproducing the issue. Start the data collection. CMD. Copy. Logman start app freeze. Simulate an application freeze. Open a resource-intensive application like Adobe Photoshop, GIMP, or even Paint.net. Open multiple large image files. Apply several filters simultaneously. If possible, script the app to consume excessive resources using automation tools. Stop data collection after observing the freeze. After experiencing the application freeze and recovering, stop the data collection. CMD. Copy. Logman stop app freeze. Analyze the collected data. Open Performance Monitor. CMD. Copy. Perfman. In the left pane, expand Data Collector Sets, User Defined. Right-click on App Freeze and select Latest Report. Review the collected data, focusing on CPU usage spikes, available memory dips, disk I/O latency increases, Page-Fault-Sec, highest resource-consuming processes. Create a basic threshold alert for future monitoring. In Performance Monitor, expand Data Collector Sets, User Defined. Right-click, User Defined, New Data Collector Set. Name it Resource Alert, and choose Create Manually next. Select Performance Counter Alert next. Click Add and select \memory available MB. \processor _total %processor time. \physical disk _total \average disk queue length. For each counter, set appropriate thresholds. Available MB below 500 megabytes. %processor time above 95%. Average disk queue length above 2. Click Next and select a location to save the alerts. Click Finish. Expected outcome. You will have captured detailed performance metrics during the application freeze and identified the specific system resources that are being exhausted. Verification. The Performance Monitor report shows clear correlations between resource constraints and application freezes, with specific processes identified as the resource consumers. Exercise 5. Using WinDBG to analyze application crashes. Objective. Learn how to use Windows Debugger, WinDBG, to analyze application crash dumps and identify root causes. Scenario. Your company's custom line of business application has been crashing frequently. You've configured Windows Error Reporting to create crash dumps, and now you need to analyze them to determine why the application is failing. Step-by-step instructions. Install Windows debugging tools. Download and install the Windows SDK, or just the debugging tools component. Alternatively, install WinDBG Preview from the Microsoft Store. Configure symbol path. Open WinDBG as administrator. In the command window, enter copy .sympath srv *c /https msdl.microsoft.com/download/symbols. Verify the symbol path was set by typing copy .sympath. Create a test application crash dump. Download and install Process Explorer from sysinternals. Launch Notepad or another simple application. Open Process Explorer. Find the application in the process list. Right-click on the process and select Create Dump, Create Full Dump. Save the dump file to a known location, e.g. c:/temp/app_crash.dmp. Alternatively, use a simulated crash. Create a simple C# application with a deliberate null reference exception or use Not My Fault tool. Open and analyze the crash dump. In WinDBG, go to File, Open Crash Dump. Navigate to and select your dump file. After the dump loads, enter the following commands in sequence. Copy. Analyze v. Review the output, which shows the exception type and location. To get more details about the crashing thread, enter copy *kb. To examine loaded modules, enter copy LMV. Interpret the debugging information. Identify the faulting module from the stack trace. Note the specific exception, e.g., access violation, null reference. Check for any third-party modules in the call stack. Examine the memory address and instruction where the crash occurred. Generate a report of your findings. Open Notepad and document. The exception type, the faulting module, the stack trace leading to the crash. Any recommendations for fixing the issue. Expected outcome. You will have successfully analyzed the crash dump and identified the specific module, function, and likely cause of the application crash. Verification. Your analysis report correctly identifies the crashing module and the type of exception that caused the crash. You can recommend specific actions to prevent future crashes. Exercise 6. Setting up proactive monitoring to detect and prevent application freezes. Objective. Implement proactive monitoring solutions to detect and alert on conditions that might lead to application freezes before they impact users. Scenario. Your company has experienced disruptive application freezes during critical business hours. The CIO has tasked you with implementing a proactive monitoring strategy to detect potential freeze conditions before they impact productivity. Step-by-step instructions. Create a PowerShell script for basic health monitoring. Open PowerShell ISC as administrator. Create a new script named freezemonitor.ps1 with the following content. PowerShell. Copy. Hashtag freezemonitor.ps1 hashtag monitor system resources for potential freeze conditions hashtag parameters $logpath equals C /logs freeze monitor. $CPU threshold equals $90 memory threshold equals $85 disk time threshold equals $90 paging threshold equals $70 run interval equals 300 hashtag seconds hashtag create log directory if it doesn't exist if test path $log path new item type directory path $log path force hashtag log function write freeze log perm string $message string $level equals info $timestamp equals get date format while on DDH SS $log entry equals $timestamp $level $message $log file equals join path $log path freeze monitor underscore plus get date format on DD plus the log add content path $log file value $log entry hashtag if warning or error also output to console if $level EQ warning or $level EQ error if $level EQ warning right host $log entry foreground color yellow else right host $log entry foreground color red hashtag alert function send freeze alert perm string $subject string $body hashtag in production replace with actual email sending write freeze log alert $subject $body level error hashtag example for actual email uncomment and customize in production hashtag sendmail message to it -alerts at company.com from monitoring at company.com subject $subject body $body SMTP server smtp.company.com hashtag create event log entry new event log name application source freeze monitor error action silently continue write event log name application source freeze monitor entry type warning event ID 1001 message $body hashtag main monitoring loop write freeze log starting freeze monitor while $true try hashtag CPU usage $CPU usage equals get counter \processor underscore total \% processor time counter samples cook value write freeze log CPU usage $CPU usage to string 0.00% $CPU usage U threshold $high CPU processes equals get process sort object CPU descending select object first 5 for each object $underscore name PID $underscore.id CPU $underscore CPU alert message equals high CPU usage detected $CPU usage to string 0.00% top processes N plus High CPU processes. Join Send Freeze Alert. High CPU usage warning. $alert message. Hashtag memory usage $OS info equals get sim instance when 32 underscore operating system $memory usage equals math : round $OS info to total visible memory size $OS info dot free physical memory / $OS info dot total visible memory size asterisk 102 write freeze log memory usage $, memory usage dot to string 0.00% if $memory usage on memory threshold $item processes equals get process sort object working set descending select object first 5 for each object $underscore name PID $underscore.id memory math : round $underscore working set / 1 megabyte 2 and $alert message equals high memory usage detected $memory usage dot to string 0.00%. Top processes N plus $item processes join send freeze alert high memory usage warning $alert message hashtag disk time $disk time equals get counter / physical disk underscore total / % disk time dot counter samples dot cooked value write freeze log disk time $disk time dot to string 0.00% if $disk time threshold $alert message equals high disk time detected $disk time dot to string 0.00%. System may experience slowdowns. Send freeze alert high disk activity warning $alert message hashtag paging file usage $paging counter equals get counter / paging file underscore total / % usage $paging usage equals $paging counter samples dot cook value write freeze log paging file usage $paging usage dot to string 0.00% if $paging usage to $paging threshold $alert message equals high paging file usage detected $paging usage dot to string 0.00%. System may experience memory pressure. Send freeze alert high paging file usage warning $alert message hashtag application hangs looking for non-responsive windows if get process where object $underscore responding EQ false non-responsive apps equals get process where object $underscore responding EQ false for each object $underscore name PID $underscore .id $alert message equals detected non-responsive applications N plus non-responsive apps join send freeze alert application not responding warning $alert message catch write freeze log error in monitoring $underscore level error start sleep seconds $run interval. Schedule the script to run at system startup. Open task scheduler. Create a new task. Name system freeze monitor. Run with highest privileges checked. Configure for your Windows version. Triggers at system startup. Actions. Action. Start a program. Program / script. PowerShell.exe. Arguments. Execution policy bypass. File C:/ scripts / freeze monitor.ps1. Conditions. Start the task only if the computer is on AC power. Unchecked. Settings. Allow task to be run on demand. Checked. Run task as soon as possible after a scheduled start is missed. Checked. If the task fails, restart every 1 minute. Attempt to restart up to 3 times. Create a PowerShell process monitoring script. Create another script named processhealthcheck.ps1. PowerShell. Copy. Hashtag processhealthcheck.ps1 hashtag monitor critical processes for signs of hangs or high resource usage hashtag list of critical processes to monitor $critical processes equals at name equals explorer max CPU equals 50 max memory MB equals 500 support email equals desktop@company.com name equals LSAS Max CPU equals 15. Max memory MB equals 150. Support email equals security@company.com. At name equals SQL Server. Max CPU equals 85. Max memory MB equals 4000. Support email equals dba@company.com. At name equals iExplore. Max CPU equals 70. Max memory MB equals 1000. Support email equals apps@company.com. At name equals W3WP. Max CPU equals 80. Max memory MB equals 2000. Support email equals webapps@company.com. Hashtag add your own critical business applications. Hashtag output file equals C:\logs/process health check _ left parenthesis get -date format. YYMEDHHMMSS.CSV. Hashtag create header for CSV file, timestamp, process name, PID, status, CPU %, memory MB, thread count, handle count, out file $output file, hashtag monitor each critical process for each. $process and $critical processes. $process info equals get process name $process name. Error action, silently continue if not. $process info, get date to string, SS, comma $process, name, n/a, not running, 0, out file $output file pen continue for each. $instance and $process info. Hashtag get process CPU usage, rough estimate. $start time equals get date $start CPU equals $instance dot total processor time start sleep milliseconds $1000 instance. Refresh. $end time equals get date $end CPU equals $instance dot total processor time $CPU usage % equals math : round $end CPU $start CPU the total seconds / $end time $start time the total seconds / environment : processor count * 102. Hashtag memory and MB memory MB equals math : round $instance working set / 1 megabyte 2. Hashtag determine status status equals normal if not $instance. Responding $status equals not responding else if $CPU usage % $process max CPU $status equals high CPU else if $memory MB process max memory MB $status equals high memory hashtag output to CSV get date to string SS comma $instance name comma $instance.id $status CPU usage % $memory MB $instance threads count comma $instance.handle count out file $output file append hashtag alert on abnormal status if $status and normal $alert message equals process $instance name PID $instance.id is in $status state n plus CPU $CPU usage % n plus memory $memory MB n plus thread count $instance threads count n plus handle count $instance.handle count hashtag in production replace with actual email sending right host alert $4 process name $alert message foreground color red hashtag create event log intro new event log name application source process health check error action silently continue write event log name application source process health check entry type warning event ID 1002 message $alert message write host process health check completed results saved to $output file schedule the process monitoring script to run periodically. Open Task Scheduler. Create another task. Name, Process Health Monitor. Run with highest privileges checked. Triggers, daily. Recur every 1 hour indefinitely. Actions. Action. Start a program. Program/script. PowerShell.exe. Arguments. Execution policy bypass. File C:\scripts \process health check .ps1. Set up Windows performance counters for baseline collection. Open an administrative command prompt. Create a baseline data collector set. CMD. Copy. Logman create counter system baseline. udomain /administrator asterisk FCSV. VMHMM. Max 50. C /logical disk asterisk /memory network interface physical disk process processor system SI 15 minutes. OC : logs system baseline. Schedule it to run during normal operations. CMD. Copy. Tasks /create /tn collect system baseline /tr logman starts system baseline /sc daily /sd 9 o'clock create /tn stop system baseline /tr logman stop system baseline /sc daily /sd 1700 hours. Configure automatic alerting for non-responsive applications. Open Event Viewer. Navigate to Application and Services Logs Microsoft Windows App Hangbe operational. Right-click and select Enable Log if it's not already enabled. Right-click again and select Create Task. General tab. Name, Application Hang Alert. Run whether user is logged on or not. Checked. Run with highest privileges. Checked. Trigger Start. New trigger begin the task. On an event. Log. Application and Services Logs /Microsoft /Windows /AppHangB operational. Source. AppHangB. Actions tab. New action. Send an email. From monitoring@company.com to it-support@company.com. Subject. Application hang detected on computer name %. Text. An application hang was detected. Please check the system. SMTP server. Your SMTP server. Click OK to save the task. Expected outcome. You'll have a comprehensive monitoring solution that proactively detects conditions likely to lead to application freezes, with automated alerting and data collection for troubleshooting. Verification. The PowerShell scripts run without errors and generate log files with resource metrics. The scheduled tasks appear in Task Scheduler and run at the specified intervals. When resource thresholds are exceeded, alerts are generated as configured.
So as we see, very detailed hands-on exercise. We can see a lot of things. We can see a lot of scripts, and actually the main advantage of Claude is the scripting capability. As we can see here, he has created already two scripts, one to monitor the freeze and another for the process monitor if it exceeds a certain threshold concerning the CPU or the memory or the hard disk. As you can see, very detailed and very organized uh, organized uh, hands-on exercise. So I think we can stop at this thing because I think it's a lot of data. In the upcoming video, with God will, we will try to explain, or we will go to the third way to explain the topic concerning a story. Okay, so this is in the upcoming video. With God will, we will see that this is a scenario between a senior IT and a junior IT. We will see how this is explained. Windows application lookup and freeze troubleshooting session. Here we will see how a senior IT is talking to a junior IT and explaining this topic in details, and how we can benefit from the learning dialogue method to explain different topics and to understand different topics. Hope this video informative to you all, and thank you all for viewing. Thank you so much.